Hi guys, and welcome back. So today I would like to talk to you about how we can actually implement a very simple rate limiter in Go. I currently have here a Gin server, which is some project I'm working on. But I want us to focus, of course, on the rate limiting part. So in case you already don't know what that is, so with rate limiting, is more or less a concept or a technique that you can actually use to control the rate at which requests are processed by a server, just to prevent scenarios whereby people decide to actually bombard your server with or try to overload it with requests. So you actually have the option to limit the amount of requests a certain client can actually make to your server. So it basically involves setting limits on the number of requests a client can make within a specific time window. And if a client exceeds this time limit, if a client exceeds this limit, then their subsequent requests are temporarily blocked and or more or less throttled until the time window basically resets itself. And there are a couple of reasons why you might want to do this. So again, which is the obvious one would be to prevent abuse, to basically prevent malicious clients from overwhelming the server with excessive requests, which could lead to DDoS attacks like denial of service and of course resource exhaustion. So you also could do this, of course, maybe due to fair resource allocation. So by limiting the number of requests that a given client can actually make, we basically ensure that resources are distributed fairly among all clients, so preventing a singular client from monopolizing their server's resources. Okay, so the next reason, of course, would be for cost control. We are, if you think about it, if we have a scenario whereby we have servers that interact with third-party services or APIs that are actually charged on the demand. So having to do something like this kind of already, of course, save cost. And overall, the benefit for me would be, of course, something like performance optimization, where we have the option of maintaining like an optimal performance, by preventing the server from being overloaded with too many requests, which could basically lead to slow responses, or server crashes more or less. So that's really what we're going to do today. We'll try to implement a quite simple basic one. I'll keep it simple, but the point is, I would like you to, of course, understand what this would really do and how you could implement one, or more or less for you to understand how this works in essence. So if you decide to use some third-party libraries, you would probably guess what happens under the hood. So our implementation is going to have four basic components. So it's going to have, of course, like a rate limiter middleware. So our implementation will actually be appended more or less to all our incoming requests as a middleware. We would also have like the token bucket implementation, and I'm going to say a few words about this, of course. It's going to have like a configuration and a customization option where you get to decide the limits, the reset time, and stuff like that. And we also throw in some error handling and responses so that if we have or if we work with other developers, they can get some meaningful responses back when they encounter this error, basically. So regarding the token bucket algorithm, there are of course so many ways you can implement rate limiting within your server. And but why this is interesting, of course, is I think it's also fairly easy to implement and also more or less a lot easier to understand. So to actually understand how this works under the hood, you can actually imagine that we have an actual bucket that we pre-populate, for example, with tokens over time. So you can then think like when a client actually makes a request to this server, we basically consume a token from these buckets, which needs to, of course, be consumed at a certain rate over time. So how this then would work, of course, would be if the more requests the user makes, the more he actually consumes token from these buckets. So it simply means the faster he consumes the tokens from the buckets, the faster he would, of course, be denied subsequent requests. But of course, the token would be refilled over time. But of course, we now decide how often we want to refill this token, so that if a client consumes these tokens much faster, it means subsequent requests will be denied until the bucket is again pre-populated with new tokens. That's really the whole concept here. So now we're going to quickly just going to jump in here and start our implementation. I already created a file and I named this token bucket. Again, don't worry about this whole other bunch of files down here. That's really not our concern. So I want us to just make our implementation in here. And I'm just going to come in here and define a struct. So I'm going to define a struct, and I'm going to call this token bucket like this. It's going to have a couple of attributes. So it's going to have tokens, which is going to be for now in 64. It's going to have a capacity. So again, you decide the capacity of the bucket basically. Again, I'm just going to make this in 64 for now because I want to give us to be able to give the user of our package or library, whatever, the option to actually configure this. And if they want to go crazy, well, they should be able to do so. And I want to add also a fill rate. I want to determine the rate at which the token in the bucket is pre-populated as they are consumed. So I'm going to make this a float 64. And again, I want to note the last time we made a refill. So I'm going to call this last refill. This is going to be of type time. And the last thing I want to have in here will be a mutex because this would be, of course, shared with all the requests that a given client would be making. So I would like this, of course, to be behind the mutex. So I'm going to get this from sync package. And this would define our basic token buckets struct. Okay, so now we're just going to go ahead and start implementing the necessary components of our limiter. So I'm going to create a function here that's going to allow us to initialize a new token bucket. So I call this new token bucket. So this is going to take a field interval, which of course is going to be of time of type duration. And again, it's going to take a capacity, which is going to be of type in 64, as you can already imagine. Now this should be able to give us back a token bucket like this. So now here I simply just return a token bucket, as simple as this. And now of course I pre-populate this with with all the values that the user has provided us with. So tokens, what is this token? So I'm gonna set token to capacity. You would also, of course, I think you would can already guess why we are doing this. So again, we have our capacity. So now I'm going to add fuel rate. So fuel rate is going to be, I'll try to more or less try to find the rate between the capacity and the fuel interval basically. So I would need to divide capacity by fuel interval dot seconds. And no, I don't want to convert this to if in 64. Rather, I would maybe convert this one to a float 64. To float 64 like this. And of course, the last thing I would want to populate, of course, will be the last field, which is simply going to be our current time. So this is actually all we need to initialize our token buckets, as simple as that. So now I'd like to add, of course, a few functions here. I'd like to add a function called take available. So this, of course, it sounds basically like what the name implies. So when we have available token, you should be able to consume it. Otherwise, then it shouldn't. If we've run out of tokens, then that's it. So I'm going to pass this, of course, as a reference. So this would be of type token bucket, and the function name would be take available. And it's going to take count basically, which is going to be of type 64. And it's going to, of course, tell me if I have the option of actually consuming a token or not. So if we have something available, then that's totally fine. Otherwise, we shouldn't be able to. So anyways, before I do anything, I would like to, of course, lock the resource because again, it's going to be behind. It's going to be it's going to be a shared resource anyways. And then I defer the unlock simple as this. And now down here, of course, I do my implementation. And before that, I would like to have a function that's going to help me to refill this token bucket. Again, it's going to look exactly like, so I'm just going to copy this part to make things a lot faster. And then I define the function refill. It's going to be a private function, I guess, so we shouldn't be able to call it outside of this package. So in here, what we'll do is quite straightforward. I'm going to define the time, which is going to be the time, the current time we tried to, of course, do this. So I'm going to time.now, and I check elapsed time from the last time we actually refilled. So I'll call this elapsed time, and this should be now that you should be able to subtract the time that we did the last refill. So simply do a tb.last refill like this, and now we have our elapsed time. So now I can maybe do a refill. So I'd say tb dot last refill, and I set this to now. And tb dot tokens, I would like to, of course, also now do the actual update of our tokens. And I would need a helper function. I'm going to come down here and define a function called min. So it's going to be able to tell me if I should do this or not. So it's going to take two items which are going to be of int64, and again give me back an int64 basically. And what is this? What it's going to do is pretty straightforward. So I'm just going to compare these two values. So if this a is less than b, basically I would like to come on return a, otherwise I'm just going to return b. Okay, so now I can actually come here and use that function, and now I need to provide the token and of course the capacity. And these are the two things I'm going to be using for comparison. So I can say tb.token, and of course I would like to add the elapsed time multiplied by the fill rate to this. So I'm going to convert this, of course, anyways to int64, and then in here I'll pass the elapsed time, that's seconds. I need this in seconds, and I'll multiply this by my fill rate. And other than this, I'll also add the capacity. So I'm basically comparing these two arguments, what you see over here, and of course the capacity, to decide the number of tokens I populate my tokens with. So having defined that, I can now come back up here to call this function. So I can say tb for token bucket, and I call the refill method. And now I can simply do a check. So I can say tb.token. If this token is greater than or equal to count. So if the tokens we have, of course, is more than the count, which is more or less us actually trying to consume this token. If that's the case, then we would allow the consumption of the token. So I'm simply just going to subtract from the tokens with this count, and then I return true. But if that's not the case, that means we've run out of tokens, and I'm going to just simply going to return false. As simple as this. And that's more or less all the methods I would like to implement for a token bucket, as simple as that. And so what we would now basically do is to go over to our middleware to make the implementation, try to use what we've done here, and then see how this behaves in essence. Now I'm going to come over to our rate limiter middleware. I'll also again just create the file. I have a bunch of middlewares in there already, but again, let's focus on this one over here. So I'm just going to come over here and define our middleware. It's also going to be pretty straightforward. If you remember what we did sometime in the past, I'm just going to call this rate limiter like this. And to initialize this middleware, I would like to pass it two arguments. So one would be our fill interval, which is going to be of type time dot duration, and the next thing I would pass would be our capacity, because we want the user to be able to decide for themselves the amount of capacity they want to give their rate limiter. And in the end, we need to return a handle func. Otherwise, this would not be meaningful middleware, more or less. Okay, so up here, I'm going to define buckets, and this would be quite straightforward. I'm going to use the make function to actually do this. So I'm going to create a map of strings and of course our token bucket. So this is going to come from my config package like this. And now I have my buckets, and the next thing of course I would like to do is to create my mutex. And this is also going to be pretty straightforward. So I can simply call sync.mutex like this. And with these two defined, I can actually now go ahead and create my middleware. So I return my function, which should be a function that takes a gin context like this. And this, of course, what we are returning. So the first thing, of course, I need is the client IP, which is more or less going to be like the key in our map. This is how we can notify like a given client when they start making a request to our server. And to get this is also pretty straightforward. We have a helper function called client IP. So we have this, and now I can, of course, instantiate my bucket. So it's again pretty straightforward. I'll try to see if we already have a bucket for these clients. So I have buckets, and then I pass my client IP. Okay, so if we do not have this client already, so again, I simply say if not okay, which means if we do not have a bucket already created to hold the tokens for this given client. If that's the case, then we basically just go ahead and create this. So I'm going to do a lock, of course. So I call this mute. It should just be mu. And now I lock this. And of course, I defer the unlock mu that's unlock. And then what I can simply do is pretty straightforward. So I need to initialize a bucket for this user. So this bucket should of course be config.new token buckets. And now I simply pass my fuel interval and my capacity. And that's really it. Now we have a bucket for this client. And now all we have to do is of course add it to our map. So now I can say buckets and client IP would of course be these buckets, as simple as this. And this will only happen if we do not have a bucket already created for a given client. But at this point, this client should already have one created. So now we simply check if he has enough tokens to proceed. Already we have a helper function called take available. So we simply call this and of course pass our counts. I'm just going to say one because I want us to consume our tokens one by one, not more than that. So if we still have some token, of course, we would further this request to maybe the next middleware or to the handler itself. That our backend, of course, needs to talk to. But if that's not the case, what we have to do here is simply abort this request. So I'm going to say abort with status JSON, which is this one, and I need to provide the status code. So I'll simply say HTTP status too many requests, this one, and I need to actually pass some information. So I use this header objects, and I can pass additional info here. I'm just gonna maybe pass an error, and I would maybe write to the user and I say too many requests like this, and then I can maybe give them some info and I say retry after, for example. And in here, I can call buckets dot retry after, and this needs to be in seconds, basically. And that's really all we need to do more or less to implement our middleware. It's pretty straightforward because we've already abstracted most of the implementations to our token bucket algorithm, which already did a few minutes ago. And now what I would try to do, of course, would be to try to add this to our API, and then we test it out to see actually how it behaves. Now I'm going to go over here to my API definitions to add this middleware here. So here I'm going to call middleware middleware dot rate limiter, and then in here I would like to of course provide the duration and the capacity. So I'm going to say time dot duration, and sorry, this should be time that's maybe seconds, and I can say within a 5-second window I would like this client to be able to use to consume only 10 tokens. That's really what I'm saying here, based of course off of how we have defined this limiter. So in essence, it simply means within a space of 5 seconds I'm going to be giving in every client 10 tokens, more or less, allowing them to make 10 requests to the server, not more than that. So again, you can, depending on what kind of server you've built and the capabilities and the functionalities, you can of course decide what these numbers could be. You can play around with them, of course, and that basically depends on you. And to test it out, I have already, of course, created this request, which is going to my API endpoints, which of course should be this one over here. So if I send a simple request, of course, the server is not up, so I simply start the server. Let's see, give that a couple of seconds, and it should be up. So now I send the request. And now this, of course, returns back a response as is expected. But of course, what I can do is just send multiple requests. So just to basically see what happens. And after a while, you also see us get this error here. And if I also do this over time, I see this because again, when I run out of tokens, more or less, if I try to send more than 10 requests within a 5 seconds window, I run out of all the tokens I have. And then over time, of course, it gets populated one more time. And again, I'm allowed to make further requests. So basically, this is behaving as we would expect. So as you can see in this simple example, it's really pretty straightforward. When a client exceeds the rate limit, we return a HTTP status too many requests. Like that's also this 429 status code you see down here. And with some JSON response saying, of course, too many requests. That's also what you see over here, pretty straightforward. So the calculation here, I would of course have to revisit, but the point now is having implemented something like this, if we are collaborating with other developers, this is of course a quite useful information. Where we say, okay, retry after say, I don't know, 20 seconds, 10 seconds, 5 seconds. The interesting thing now is if this is an API that other APIs would consume, now we have given them an option to for example, implement a backup strategy, where they decide now based on, of course, this response when next to make or retry this request, like using some backup strategy, and that's really the important. And so we're not just saying returning a 429 status code, but of course we're also providing additional meaningful information that the consumers of our API also knows how to react based off of the message we're giving them. So anyway, guys, that was a really quick one, and I also hope it was a much more informative one. There are of course a lot more strategies, a lot more algorithms that people of course employ when it comes to implementing a rate limiter to their server. But for now, I think this should suffice for us. This also of course does the job. It's also quite popular, and so that's also why I chose to talk to you about this in this tutorial. Anyway, guys, that's really all I wanted to show you in this tutorial. That would be all, guys, and I think we'll have to draw the curtain here. So until we see each other next time, guys, have a lovely evening. Stay well. Bye bye.